it's important that you use the correct torque. So be sure to refer to the service manual for specifications. Timing belts on the 3.2 and 3.5 liter engines now need to be serviced only every 105,000 miles. In other areas of the engine compartment, you'll notice the reservoir for the power steering fluid is now translucent, making it easy to check fluid level without removing the cap. And the power steering filler neck has been repositioned. Now adding power steering fluid is even easier. The new radiator uses tandem transmission oil coolers, one internal and one external. The internal component is an oil-to-coolant heat exchanger, while the external component is an oil-to-air heat exchanger. This new configuration allows for increased transmission cooling capacity. A new coolant is used that will affect service. This is a Mopar 5-year, 100,000-mile antifreeze coolant. Keep in mind this coolant shouldn't be used in combination with any other, as the new mixture will lack the correct amount of corrosion inhibitor formula, greatly reducing its effectiveness. An updated air conditioning condenser provides a greater heat transfer area for enhanced cooling performance. Redesigned dual cooling fans run faster, moving more air with less noise than that of the previous design. For the first time ever, a coolant pressure bottle and an overflow reservoir are used on the same vehicle. In fact, the coolant pressure bottle and overflow reservoir have been combined. Coolant from the pressure bottle is released into the normally empty reservoir. Once the engine cools, the coolant is returned to the system. The Powertrain Control Module, or PCM, which is also called the SBEC3A, is located under the cruise control servo and now has a faster microprocessor and double the memory. The SBEC3A supports the new bus, the PCI bus, which you learned about in the November Mastertech, and which we'll be discussing a little later. Speaking of which, a lower engine idle speed of 525 RPM results in reduced fuel consumption during idling. The Transmission Control Module, or TCM, which is also referred to as the ETAX3A, is located next to the PCM and also supports the PCI bus. The battery has been relocated to the front fender well and front of the tire. If necessary, the battery positive terminal can be accessed behind the right headlight, and the battery negative terminal is on the right strut tower. The power distribution center contains micro relays and F-type cartridge fuses, which take up minimal space. This new, slightly larger PDC houses many more components than in the past. In a minute, we're going to take a look at some of the changes that have occurred under the vehicle. But before we go any further, let's try a review question. Which of the following features does not apply to the 3.5-liter engine? A, Y-shaped exhaust roller rocker arms. B, multi-layered steel head gasket. C, gasketless spark plugs. Or D, cast-in-place cast iron cylinder liners. The correct answer is C. Spark plugs used in the 3.5-liter engine can be identified by their use of a gasket. If you watched last October's Mastertech program, you know that the 42LE Transaxle, used with 3.2 and 3.5-liter engines, has a different overall top gear ratio than the one used on 2.7-liter engines. October's program also covered some of the internal changes to all 42LE Transaxles. Autostick is standard equipment on the 300M and Intrepid ES. The autostick feature allows drivers the option of manual upshifts and downshifts. The TCM on these vehicles has been refined to provide crisp shifts and allow the engine to rev higher to provide maximum acceleration. However, once the engine reaches the rev limit, the TCM will override the autostick feature and automatically force an upshift. Communication between the TCM and PCM has been improved to provide better shift quality. For example, during coast-down shifts, the PCM interrupts air conditioning compressor operation to help provide seamless shifting. Looking at fuel systems, like the Concorde and Intrepid, LHS and 300M use a returnless fuel system. The fuel supply system now uses an onboard refueling vapor recovery, or ORVR system. Designed to prevent fuel vapors from escaping to the atmosphere, the ORVR system consists of a new, smaller diameter filler tube with a tapered design, which guides the filler nozzle into place. A one-way check valve located at the tank inlet that closes when the tank is full, preventing fuel from spitting back out the filler tube. During refueling, when the fuel tank is full, the valve will close, causing pressure to build up in the tank. As a result, the filler nozzle will shut off. Finally, the ORVR system uses a vapor outlet control valve on top of the fuel tank to control vapor flow to the evaporative canister. And speaking of the evaporative canister, notice that it's now mounted directly on the fuel tank. A proportional purge solenoid valve located in the engine compartment controls the flow of vapors from the evaporative canister to the intake manifold for combustion by the engine. In the area of service, removing the fuel tank is easier now because you no longer have to remove the rear suspension crossmember first. The fuel pump assembly consists of the primary fuel filter, the secondary fuel filter, and fuel pressure regulator, which are combined as a unit, a fuel gauge sending unit, and a fuel reservoir, which ensures the pump has a continuous supply of fuel at low fuel levels. Vehicles with the California emissions package are equipped with a leak detection pump, which is used to detect leaks in the evaporative control system. For more information about the leak detection pump, refer to the July 1996 Mastertech. We've already seen some of the changes to emissions control on the LHS and 300M, but other changes have been made to the engine and emission system to ensure that vehicles continue to run as cleanly as possible. Some changes were aimed at ensuring complete combustion and accurate fuel metering. For example, the top piston ring is closer to the piston crown, minimizing the space where the fuel-air mixture can escape complete combustion. Coil on-plug ignition provides more energy for improved combustion than the distributorless ignition system used previously. On 3.2 and 3.5-liter engines, a combined intake air temperature sensor and manifold absolute pressure sensor, or TMAP, provides more accurate temperature readings than the previous intake air temperature sensor. New oxygen sensors located before and after the catalytic converters are less susceptible to damage. A couple changes were aimed at helping the catalytic converter warm up more quickly. Low-mass exhaust manifolds absorb little heat from the exhaust stream, speeding up catalytic converter warm-up. Dual catalytic converters are connected right to the exhaust manifolds. Because of their proximity to the engine, they are able to reach operating temperature faster. The exhaust system has undergone some changes too. First, V-band clamps connect the exhaust manifolds to the catalytic converters and provide effective sealing. Since these clamps cannot be reused, once they're removed, they must be replaced. The stainless steel exhaust system has an aluminized coating for durability as well as appearance. The exhaust pipe joints are connected with band-type clamps that make pipes easier to separate, enhancing serviceability. The LHS and 300M have dual exhaust outlets, and the exhaust tips on the LHS and Intrepid ES are chrome-plated. Looking at steering, power rack and pinion is standard equipment on all of these vehicles. A new steering gear mounting bracket attaches to the body crossmember through two rubber bushings. Steering changes include single bolt pinch clamps replacing jam nuts to retain tie rod adjustment. An auxiliary power steering fluid cooler increases fluid and component longevity. Increased pump capacity guarantees that assist is available even during abrupt maneuvering. The speed-sensitive variable assist power steering, which is standard on the LHS, no longer uses a solenoid control module. Now it's controlled by the BCM. The BCM uses the vehicle speed signal to control the speed proportional steering solenoid, located on the steering rack. The SPS solenoid will then regulate system back pressure in the valve assembly. The suspension on the LHS is similar to that on the Concorde and Intrepid. However, the McPherson